right, let's keep going with chapter 12 here, getting pretty close to the end of this book. Today, the Pythagorean Theorem and its converse. Converse, not just an old school retro looking tennis shoe. Let's explain what the heck that is to begin with. Well, let's start with the Pythagorean Theorem. If we have a right triangle and its legs are A and B and its hypotenuse is C, hypotenuse is the side across from the right angle, the Pythagorean theorem would read like this. If it is a right triangle, then a squared plus b squared equals c squared. That's a theorem right there. It's an if-then statement. The converse of that statement would be where you flip around the two parts of the sentence. So we could say if a squared plus b squared equals c squared, then it must be a right triangle. Okay, both of these are true statements. So again, A and B we're using as labels for the legs of a hypotenuse, the sides touching the right angle. C would be the hypotenuse of a right triangle. All right, so very basic problem here with the Pythagorean theorem. Knowing the Pythagorean theorem, if we know two of the sides, we can figure out the third side of a right triangle, whether it is a leg or a hypotenuse. In this case, we are missing the hypotenuse. Let's figure it out. So a squared plus b squared equals c squared is the Pythagorean theorem. Let's use legs of 8 and 15, and the hypotenuse is x squared. I'm sorry, the hypotenuse is x. In the theorem, we're going to square it. It does not matter if you call a 15 and b 8. 64 plus 225 is the same as 225 plus 64, so it doesn't matter what order you put the legs in. But it is very essential that you plug in x for c, since x is the hypotenuse and c is used to represent the hypotenuse. Keep going on this. We'll add those two numbers. 289 equals x squared. And then we'll solve this by taking the square root of both sides. So x is 17. Couple key things about the Pythagorean theorem. Number one, your hypotenuse should always be your longest side. So 17 is longer than 18 and 15, so that's a good look there. Number two is this equation, 289 equals x squared, actually has two solutions, positive and negative 17, but since you can't have a negative side length of a triangle, we would just ignore the negative 17. I'm not even going to bother writing it down. Here's another problem. This time we're missing one of the legs, so the Pythagorean theorem is still going to work here. I'm going to put 2 in for A and x in for B. And again, it does not matter if you switch x and 2 around, but 7 definitely needs to go in place of C. 2 squared is 4. We'll leave x squared. And 7 squared is 49. Subtract 4 from both sides and then take the square root of both sides. Square root of 45. This would be the exact distance from here to here. We could, well, first of all, it can be simplified because it's divisible by a perfect square, 9. So we could say that it's 3 times the square root of 5. Or we could round that, and the square root of 45 is also about 6.7. So either one of those would be okay. In a real world setting, you'd probably say this, but if you need the exact distance, you would say 3 times the square root of 5. Okay, a right triangle has a hypotenuse that is 1 foot longer than the, 1 foot longer than the longer leg. The shorter leg is 9 feet. Find the missing lengths. I definitely need to draw a picture for this. So, has a hypotenuse that is 1 foot longer than the longer leg. So here's the hypotenuse. Here's the longer leg, x. I don't know what it is, so I'll just call it x. The hypotenuse, though, I know is 1 foot longer, so it's x plus 1. The shorter leg they flat out give us is 9. Okay, a squared plus b squared equals c squared. Let's find out what x is. A we're going to call 9, b we're going to call x, and c we're going to call the quantity x plus 1. All right, so 9 squared is 81, x squared is x squared, x plus 1 squared, that's x plus 1 times x plus 1. X squared plus 2x plus 1. We got a quadratic equation, but there's x squareds on both sides, so we just ignore those. So 81, subtract 1 from both sides, and you'll get 80. On the right, you'll get 2x. Divide both sides by 2, you get 40. And there we go. The longer leg is 40. We want to know the hypotenuse too, which is x plus 1. That's going to be 40 plus 1, 41. So thought we might have to do something with quadratic equation there, but not quite, because the x squareds just cancel each other out since there's one on each side. Now let's use the converse of the Pythagorean theorem. This says determine whether the lengths of the sides are a right triangle. Well, if they fit the Pythagorean theorem, then they should be a right triangle. So if a squared plus b squared equals c squared, leg 1 plus squared plus leg 2 squared equals the hypotenuse squared, then this will be a right triangle. If not, not possible for it to be a right triangle. Okay, so 0.5 squared plus 0.8 squared is 0.89, and 1 squared is 1. Since these are not equal values, these are not the sides of a right triangle. Might be a triangle, but not a right triangle. Okay. How about this one? Leg 1 squared plus leg 2 squared has got to equal the hypotenuse squared if this is a right triangle. Now, trying to be tricky over here by putting these out of order, but remember that the hypotenuse has always got to be the longest side, so 29, the biggest number, has got to go in for C. Don't just assume that 20 goes here and 29 goes here and 21 goes here. The longest side has got to be the hypotenuse. So 20 squared plus 21 squared is 841. 29 squared is also 841. So yes, these are the sides of a right triangle. Why don't you try this one? Press pause, and when you press play, my answer will be waiting for you. Okay, a triangle has a hypotenuse with length 34 inches. One leg is 14 inches shorter than the other leg. Find the lengths of the legs. I definitely need a picture here. Hypotenuse is 34. One leg is 14 inches shorter than the other leg. So 14 inches shorter than this leg. So we got leg 1 squared plus leg 2 squared equals hypotenuse squared. X minus 14 squared is, it's the square of a binomial pattern, guys, so hopefully we've got that down pat. This is a squared, this is b squared, and this is 2ab. Negative 14x doubled is negative 28x. That's the square of a binomial pattern. So, x squared plus x squared, combining like terms right there, is 2x squared. I also went ahead and subtracted 1,156 from both sides. So 196 minus 1156 is negative 960. All of these three are divisible by 2, so I'm going to divide them all by 2. And I got a choice here. I could try and factor this. Might not be so bad. I could use the quadratic formula. Or I could complete the square if I wanted to. That wouldn't be such a bad idea. But this is factorable. Might take a few minutes to come up with it, but I've done my legwork before doing this problem, and I know that the factors of negative 480 that add up to negative 14 are negative 30 and 16. So the solutions to my equation using the zero product property are 30 and negative 16. However, if we use negative 16, we would have a negative side of a triangle, so I'm going to ignore that. So I know that this longer leg has got to be 30. And this shorter leg has got to be 14 less, so it's 16 inches. 16 inches and 30 inches are the lengths of the legs. All right. right, how about this one? Determine whether 1.5, 2.0, and 2.5 are the lengths of the sides of a right triangle. If these are the lengths of the sides of a right triangle, then the shortest side squared plus the next shortest side squared has got to equal the hypotenuse squared. 1.5 squared plus 2 squared is 6.25, and 2.5 squared is also 6.25. So these are indeed the sides of a right triangle because they fit the Pythagorean theorem. All right. How about a real-world application here? A ladder 8 meters long is resting against a building. The bottom of the ladder is 3 meters from the wall. To the nearest tenth, how far up the wall does the ladder reach? Again, I think a diagram is going to help me. So here's my building. Put a door on there and some windows. Very stylish. The architecture here is superb. Maybe there's a person in the window and he's in there because the building's on fire. No! Oh my God, somebody get a ladder. Let's get this gentleman out. There's our ladder. Here's the fireman to the rescue. It's very important, though, that we figure out how far this ladder is up the wall. Is this ladder even going to reach him? We better stop and do this math right now. Well, the ladder's 8 meters long, and it's 3 meters away from the base of the wall. And we're trying to figure out how high up the ladder is going to reach. That's a right triangle. So a squared plus b squared should equal c squared. Remember, the ladder is the hypotenuse of the triangle. And since we're dealing real world here, I could leave it as the square root of 55 meters, but that doesn't make any sense really to most people. So we'll call it 7.4 meters. That's how high up the wall. Even though we have an 8-meter ladder, we can actually only reach 7.4 meters up. Boy, hopefully that's going to reach this guy. I think this thing's pretty scaled. I'm quite the artist. All right, one more. Erica is setting out the boundary of a tool shed that she is going to build. The building will be 8 foot long by 6 foot wide, and the diagonal of the boundary measures 11 feet. How does Erica know that the corners of her boundaries are not square? Which, of course, she probably wants them square. So it's an 8 by 6 building. She measures the diagonal, and it comes out to be 11. So all we're going to do is check the Pythagorean theorem here. Does 6 squared plus 8 squared equal 11 squared? Well, we get 100 and 121. That's how Erica knows that her corners are not square. She's going to have to get her carpentry tools out and do some refiguring. And then she could always measure the diagonal again and make sure that this distance is 10. That's what it should be. 6, 8. This distance should be 10. And then she'll know that her corners are square. All right, that's all I got for you on Pythagorean Theorem. You guys have done Pythagorean Theorem before. We've taken this a step up a little bit here, worked some quadratics into it and some radicals. So, see you tomorrow, and we'll practice this in class. Good luck.